Welcome back. In this video we're going to fix the gravity problem, because if you tested your game a little bit, you will have noticed that if you step up on something, that the game will push you up, so it will let you move up a little bit, but then you will stay up. So it doesn't pull you down anymore. So your character is floating in the air, so to speak. And as you can see, there's no gravity. So we went up, but we don't go down. And in order to change that, we are going to take care of gravity, which is basically a force added to an object over time with a value depending on a given gravity number, making it exponentially grow in speed until it reaches terminal velocity. Implementing it would be moving our character down with an increased velocity. So let's add that to our script. Therefore, let's go back to our player movement and let's make sure that we have a vector3 velocity here, velocity like this, and I'm just going to leave it at empty for the beginning. And then I also will need the gravity, so I'm just going to use the default gravity that we have on Earth, so float gravity of 9.81 F, which is 9.81 meters per second square. That's how the velocity or the gravity is on Earth. So that's how fast items accelerate, so to speak. Okay, and now what we can do is here in our controller player move, here we can make sure that our velocity is going to also have a y value that will take the old velocity plus gravity times time delta time. So just making sure that it's going to work correctly inside of the update method. Now to actually add that to our player movement script, we need to go ahead and say controller.move. And here we are going to move with the velocity also. And because physics tells us to calculate increasing velocity in a free fall, we need to multiply gravity by time squared. To do that here, we need to once more multiply our velocity by time, because velocity is already meters divided by seconds. If we now add the time delta time, then we are going to divide it by seconds squared. So this will now give us the right timing here. So that's going to be the gravity. That's how you can implement it manually without using a rigid body and all of that. That is definitely going to be relevant for our game. So let's run the game. And let's see if we can fall down again after we have walked up something. So you see gravity is pulling us back down like this. All right, so that is pretty much it. Now you know how to add gravity to your game. And our only issue is that velocity just keeps increasing indefinitely as if we were in a constant free fall, but we obviously aren't. So let's add a way to let our script know that we are indeed on the ground. Therefore, inside of our player character, so inside of the first person player here, not the FPS character, but the first person player, let's create an empty game object. I'm going to call this one ground check. While we're at it, we can also give it a little bit of a gizmo here, because otherwise we won't see it properly. Let's also make sure that ground check is going to be at 0, 0, 0. And here for the Y position, it shouldn't be inside of the player, but maybe a little further down. So minus 1.4 should be good, because now this square will be inside of the ground, so to speak. Okay, because our character, if we look at it here, it's at 1.5. So it will be just at the edge. We can play around with this value later if we're not happy with it in the end. So for our ground check. Now let's go over to our player movement here and let's add another variable here. Public bool is grounded. So this one will know or will indicate whether we are grounded or not. So inside of the update method, we can use a cool method here. So is grounded. We're going to set that to physics.checkSphere. So what that will do is returns true if there are any colliders overlapping the sphere defined by position and radius in world coordinates. So let's just do that. Now this check sphere isn't very happy because you see it needs a position, a radius, a layer mask, and then there are multiple overloads that we can use, but we're going to use the one with those three. So we need to set those three up. So let's create, first of all, a transform, public transform. I'm going to call this one ground check. Then a ground distance. So here ground distance, which will be, let's say 0.4f. We can also play around with this value. And then we need to set the layer. So here public layer mask that I'm going to call ground mask. So this layer mask, by the way, specifies layers to use in a physical raycast. And this layer mask will allow us to know which layer we are at. So now we need to pass those values. So let's pass those values here. Ground check dot position, then the ground distance, as well as the ground mask that we just set up. And then the check sphere method will be happy. So now what we can check is if is grounded and the velocity towards the y coordinate is less than 0, then let's run some code. So what we want to do here is we want to change the velocity of y to be -2f. This will give us a small landing transition of some sort. Okay, so it's not like we are going to have no velocity towards the y coordinate at all. This will make the grounding process a little smoother, because in the next video we're going to see how to jump as well, and this is a little trick to make it a little smoother. As well as pressing the player to the ground removes the possibility of floating, because we really want to make sure that we're not floating. All right, now let's save this script and let's make sure that our first person player here has a certain, well, let's apply the changes that we made. And now let's look at the layers, because so far we have not really used layers, right? But there is on one hand the tag, but then there is also the layer. So the transparent FX layer, water layer, UI layer, and we can now add another layer, and I'm going to add it here on the layer 6 position, and I'm going to call this one ground. Okay, so this ground will now be my new layer. Let's make sure that we add that here. And now back in our first person player, we need to make sure that the mask is using the ground setting here. So the ground mask will use our new layer that we added, the ground layer here. So let me use ground once again like this. So now here we need to make sure that our street is going to be the ground. So only if we are on the street, we want to use this ground layer. Okay, so really make sure that we change the children here. Okay, we need to make sure that all of the children inside of my street have this layer ground to them. Because now, if we are on the ground, we know that we don't need to fall further down. So we don't need a velocity that pulls the player down. Okay, so that's one way of doing it, of course. So you see, when you're not using rigid bodies for movement and for physics, there are a lot of extra steps that you need to take. And now we just need to make sure that the ground check that we're using here is added to the ground check setting. So here the ground check of our main character, this extra component that we created, let's make sure that we are dragging it into our first person player ground check property here. By the way, make sure that the player itself has a default, right? We just added the ground, but we don't need the ground layer for our player. We really just need it for the streets, okay, in our city. Now you also might want to add the ground layer to other items that you want to be able to jump on. For example, those blocks here, or for example, also the vehicles that you have here, the decorations like such as the cars and stuff like that. So add the ground layer to whatever you want to be able to jump on and not use gravity dragging you down for. So let's test this. Let's see if we can actually now be pulled down properly with the right gravity. Well, we have the smooth effect, I'd say. So it feels smooth how we're dropping down. It doesn't feel super off or anything, right? Okay, and now let me check it without maximize on display. So here you can then also check your character out and see the y value here. The position is at 1.43, and you can see we have a little bit of gravity pulling us down, like so. And in the next video, we're going to see how we can use jumping, and then you can see the gravity in action even better. So see you there.